Hello everyone, I am Rupa, working as an assistant professor in Gokaraju Rangaraju Institute of Engineering and Technology. Now I will discuss about task 3 in data warehousing, data mining and business intelligence lab. Before going to discuss about task 3, we will see which software we will use for this experiment and the introduction about the software. Then we can go for the task 3. The software used for this task is Veka. Veka is an open source tool. By using this Veka open source tool, we can execute this task. We'll go for a simple introduction about the Veka. Okay, the abbreviation of Veka is Waikato Environment for Knowledge Analysis. It's invented by the Waikato University. They have given the name as the Waikato Environment for Knowledge Analysis. Okay, by using this Veka tool, obviously we need to retrieve hidden patterns or the hidden knowledge from the corresponding data. Veka is a open source software that provides tools for data pre-processing, implementation of several machine learning algorithms and visualization tools so that we can develop some machine learning techniques and apply them to the real world data mining problems. By using this open source Veka tool, we can implement some of the machine learning algorithms and we can mine the data by using all the algorithms. The tools used in Veka are pre-processing, classification, clustering, association, rule, attribute selection, and visualization. These are the tools available within the Veka. Now we'll see how that Veka Explorer interface has to be available. The Veka GUI has to be contained as applications as Explorer, Experimenter, Knowledge Flow, Workbench, and Simple CLI. Explorer environment for exploring data with Veka, and Experimenter environment is performing experiments and conducting statistical tests between the learning schemes. Knowledge flow means it's an environment for supports essentially the same functions as Explorer but with drag and drop options. And Workbench means it's an environment that combines all of the GUI interfaces like Explorer, Experimenter, Explorer, Knowledge Flow like that. And Simple CLI will provide the simple command line interface that allows direct execution of Veka commands. This is about the Veka interface. Now we'll see what are the things and tabs and tools are available within Veka Explorer. Within this Veka Explorer, it has the tabs as tools are pre-processed data, classification, clustering, association, rules, attribute selection, data visualization. Whatever the tasks we are doing in Veka, we can go for use this Explorer application. And first we can see the raw data. We can load the raw data. That means that is in a form as ARFF file. Then pre-process the data. And you can use some of the techniques to pre-process data. After pre-processing, then you can go for given into either classification, clustering or association or attribute selection. Each and everything has to be contained their own algorithms. In classification, we have a navigation, random forest, decision tree, linear regression, logistic regression, etc. And in clustering, we have a k-means algorithm, k-method algorithm, some hierarchical algorithms and density-based algorithms are available. And in association, we have a a priori algorithm, FP growth algorithms, and so on. And in attribute selection, we have some evaluation methods has to be available. By using those methods, so the attributes has to be selected. Finally, whatever the output has to be coming from any of these things, that has to be represented by using this visualization tool. It's in a form as a table, charts, graphs, and any of the visualization representation. Now we'll see the exactly what is there in task 3. In task 3, the one approach for solving the problem encountered in the previous task is using cross-validation. That means here we can apply the cross-validation. Previously we are using as a training data set. Now we can apply the cross-validation for the corresponding ARFF file, corresponding attributes, and describe what is cross-validation briefly. I will explain this one. And train a decision tree using cross-validation and report your results. We will check what is the results has to be get by applying this cross-validation, and we will compare with how much we are getting for a training set and how much we are getting for the cross-validation. Does your accuracy will increase or decrease? We will check whether it is increase or decrease. I think you remember that by using the training set, we got an accuracy as 85.5%. Now we will see whether that accuracy will be increase or decrease. Why? We will discuss that one. First, we will see what is meant by cross-validation. It is a resampling procedure used to evaluate the machine learning models on a limited data sample. We have some whole data set has to be available. We can resample that one. We need to take some sample of data and we can apply classification. The procedure has a single parameter called a k that refers to the number of groups that a given data sample is to be split into. As such, the procedure often called k-fold cross-validation. Here we can call it as a k-fold cross-validation. Based on the k value, the folds has to be there, the data sample has to be divided. When a specific value for k When a specific value for k is chosen, it may be used in place of k in the reference to the model, such as k is equal 10 becoming 10-fold cross-validation. If the k is equal 5, it becomes 5-fold cross-validation. We will see with an example. Okay, we have a k-fold cross-validation method. Based on this k value, we can decide it as a 10-fold or 5-fold or 3-fold and like that. The first step is we can divide the sample data into k parts. Divide into k parts and use k minus 1 parts for the training and 1 for the testing. Okay, 1 is for testing, remaining parts is for the training. Repeat the procedure for k times, rotate the test set. We can change the test set for every iteration and determine expected performance metric as mean square error, misclassification error rate, and you can apply that one, and based on the results across all the iterations. Okay, you can determine the performance of the each and every iteration. Okay, let us observe this one. We have a whole data set has to be available, divided into the splits, folds, and k minus 1 we can given to the training set, and 1 is for the test. Okay, again you can change the test and remaining will be the training. That has to be done for all the iterations, for all the k parts. If it is divided into 10 folds, the 10 iterations has to be there. Every time the test fold has to be changed for each and every iteration. Now we can find what is the accuracy for each and every iteration. Now let us observe this one. We have in first iteration, they are divided into some part as a training set and one part to some part will be the test set here. Again for second iteration, it has to be changed. They have considered it as the 5 things has to be comes under test set. The remaining are training. Again one more 5 points they are considered as a test and remaining is training for second iteration. And in third iteration as usual like that it has to be going for the all the data. Okay, like this, observe this one. We have a data is there and training test. Again we need to change this test and remaining is training. Again we need to change the test and remaining is a training. Okay, like that to fold one, first iteration, second iteration, third iteration, and like that 5 iterations has to be there. And finally we need to take the average of all the folds. Finally we can get the performance of the all the folds. Now we will see how to execute this task in Veka environment. Open Veka. Open Veka here. It contains applications as Explorer, Experimenter, all these things. Go to Explorer application. Click on this one. Explorer. And it opens the window like this. Okay. First we need to load the ARFF file. Okay, already I said that whatever the task we are doing in Veka, we are using the German credit ARFF file. And click on under pre-processing tab, open this file, open file. The file is available within C drive, program files, and Veka folder, and data folder. Under data folder, we have ARFF files are available. Select credit German ARFF file, credit -G ARFF. Open this one. Now as usual it contains all the 20 attributes and next one is a class label. 21 are the 20 is attributes and 1 is a class label. Then go to classify tab. Previously we are using the use training set. Okay, now we have 4 options are there right here. Use training set, supply test, cross validation. Here we need to choose this cross validation. Here you can change these folds. 10 or 5 whatever is required. Here we will apply the 10 folds and you can choose the same trees. Click on choose trees and select J48 tree. Okay, and click on this start. Okay, it shows the accuracy here. Correctly classified instances are 705, that will give us 70.5, and incorrectly classified instances are 295, that gives the accuracy as 29.5. That means the accuracy for correctly classified is 70.5. Okay, you can observe this one. Previously, whenever if you want to use this use training set, we got 85.5%. Okay, by applying this cross validation, we got only 70.5%. Okay, why? Because here we are applying the resampling technique. Every time the test has to be changed, the training has to be changed. Because of this one, obviously, so for some data sets, the accuracy has to be decreases compared to the whole training set. Okay, whenever we can apply the cross validation, we can compare to the training set, accuracy has to be reduced here. Thank you.